Welcome back, chemistry fans. Today we're going to do Unit 1, and I believe this is topic 6, and this is our topic talking about the periodic trends, periodicity. Let's jump right into the homework here. If I can find it. There it is. All right, first off, define atomic radius. Simple. It is not that I want the technical definition of what a of what the atomic radius is. I'm looking more for something that is along the lines of size of atom. That's what I want you to be able to tell me. That's the generic sense of it. Now, yes, we could get down to it and say that it is the distance between the nucleus of two atoms divided by 2. Now, that's the definition of atomic radius, but that doesn't tell me anything. What I'm wanting you to be able to say is, if I look at the periodic table, and I have this element versus this element, which element is larger? That's what atomic radius does. It gives us the sense of the size of the atom, which atom is bigger. Okay, number 2, speaking of which element, chlorine or fluorine, is bigger? So let's take a look at a periodic table so that we can determine chlorine versus fluorine, which one is going to be bigger. Now, they are right next to one another. And what you need to know is that as you go down the periodic table, you add energy levels. So fluorine is on the second. It would have 9 electrons, but that's irrespective. What's more important is the fact that it has 2 rings. And then if we look at chlorine, it is on the third. Just by the fact that it has more rings means that chlorine is going to be the larger of the atoms. Let me pull this closer to the homework so that we can do that together. Okay, so chlorine is going to be our answer right there. Okay, electronegativity. Again, I could give you a definition such as that it is a relative scale of the ability to pull electrons from another atom. Okay, but that's a technical definition. What I would rather you be able to tell me is who protects their electrons, who steals electrons better. That's the better story that I'm wanting you to tell me. Electronegativity is who wants electrons. So if we look at our periodic table, elements that are closer to their stable octet are going to want to steal electrons to complete the octet. If you're further away from your octet, you're going to want to give away electrons. So that's the whole story. So now we're going to do a comparison, bromine versus calcium. So let's take a look on a periodic table, bromine versus calcium. Bromine, again, over on the right, calcium over on the left. Now, because of this, calcium has 2 valence electrons, where bromine has 7. Bromine is closer to a stable octet. It is going to want to steal electrons, and the exact opposite is what's going to happen for calcium. Calcium is going to be giving away its electrons. So we will see that bromine will have the higher electronegativity. All right, last term is ionization energy. This is the exact same trend, but in the opposite. It's who protects their electrons better. So if you are, again, close to a stable octet, you are not going to want to give away your electrons. In fact, you are going to want to protect and hold on to them, because all you need is just a few more to complete the stable octet. On the other side, if you have a whole bunch of electrons and you have some extras, you're going to be willing to get rid of them. So your ionization energy will be low. You will have high ionization energy if you protect your electrons. So here we are with barium and sulfur. Let's take a look at where they are. Barium down here, sulfur down here. Now, by the very nature of having a lot of electrons, barium is probably going to have a lower ionization energy. However, it's also a part of the story, though, that sulfur has 6 valence electrons versus barium's 2. Barium needs 6. It doesn't care if you steal some of its electrons. Sulfur has 6. It's going to want to protect them because it's very close to its stable octet. So the sulfur is going to have the higher ionization energy because it wants to protect its electrons. Okay, this is everything that I hope that you are able to tell me about the trends on the periodic table. Thank you very much. Talk to you again soon. Farewell.